I hope that makes sense.
Like, yeah, makes sense. I get you.
Cool. Then we have another thing here. Should workloads storing data? Because we know that our software is going to be able to store data one way or the other. People will need to sign into the website and we need to store their password, the credentials. If it's a solution like Facebook or Instagram, for example, people upload their videos and pictures. So it has to store data somehow. So the question now is, okay, when we are logically grouping our infrastructure, we want to make sure that all the computational servers and workloads are also living in the same place as where our data is kept. That's one question. Does that fit into the requirement? Does the business require that every computational workload, and when I say computational workload, I mean the servers that are running the software. That's where CPU is being used. That's where RAM, your memory is being used, things like that. So the server that is actually running either is Java, Node.js, or PHP, whatever the language you've developed your application with, the server that is running that is what I'm referring to as computational workload. Now, these servers will run the application. The application will accept data from the users and ultimately store it in some backend database. So whatever you're using for your database, the network that infrastructure is going to be, should it be within the same network that your computational workload should be? That's one question you want to answer. And when we're designing our infrastructure, we can begin to draw it out and see if it makes sense to put it in there. If the business requires that no, it has to be separated, then we have to design how it has to be separated and the possibility of making that to work. Now, there are some requirements that just can't be fulfilled just because of the way those tools or resources work in AWS. And we'll see some examples like that. Then the other thing is, should our servers be accessible directly over the public network? So, like I said earlier on, we need our website, for example, Diary.io, but when you create a network in AWS, by default, it is private. So how is that going to be? Well, AWS also provides a solution for that. And that's where you now think about the AWS component that makes it possible to make the website accessible to people over the network. Okay? Then how should our engineers access servers in the private network, since private servers can never be reached over the internet? So again, it satisfies the similar question about how we are able to access the infrastructure over the internet. First of all, we want our customers to visit the website, and they are going to be using the HTTPS protocol to access it through the browser. But how about the engineers that's working, the DevOps engineers, the database administrators, the developers? How will they access the servers? They have to use things like SSH protocol, or in the case of Windows, RDP protocol. How would they be able to access the servers running in that private network? Well, there are ways in which AWS solves that problem as well, and we'll see how that will be solved when we start drawing our architecture. Then there is the other one here that says, is there a requirement to access the product from the internet? Okay, so it's the same thing we're talking about, and possible solutions. So we need an internet gateway. So that's where the AWS specific solution for that problem comes in. And then you see how we'll now begin to deploy the internet gateway. Then we have to define the traffic route, how we want our traffic to route from one network to the other, and things like that. We need our private network to download stuff from the internet. So that's another question. So yes, we have our servers in the private network, People can reach it somehow because now we have designed how people can reach it over the internet. But how about our servers? Do we want them to go over to the internet to download stuff? Because now we're talking about two-way traffic. One is the inbound from people from the outside world. Now we're talking about outbound, which is within the network. How do we go to the internet to download stuff? Because there is need for our servers to be updated. You must have been running apt-get updates from some of the projects you've been doing from project one. You must have run yum commands as well to install packages. There are reasons why you would want to do git clone to clone your resources or your code onto the servers, depending on how the environment and how the team is structured. So these are questions that you would ask as a solution designer, and then you try to provide solutions in terms of how these problems will be solved. So possible solutions, first of all, is to have a proxy server in the gateway. So remember we talked about it, having a gateway first of all. So you can have a proxy server there that will do the initial downloading and scanning of the packages to find out whether there is virus, because what we are trying to run away from is the possibility of bringing in security vulnerabilities into our infrastructure. So once we have divided our networks, we've divided it into sub-networks. And that means we're able to isolate the network that matters the most to us. So we are downloading stuff. It's possible for us to put it in a different network, first of all, that if any hacker or any terrible person gets into our network and is able to get into that space, the damage that it will cause on our infrastructure wouldn't be as bad as if they had access to everything. So that's one of the benefits of separating our networks. So once we have a gateway network like that, it's possible to put a proxy server there and do all the initial downloads there so that you can run your antivirus tools that will do all the scanning. And if you find any vulnerabilities or any virus or whatnot, it can begin to quarantine that and put it separately. And that way we're still secure and we're taking care of the infrastructure nicely. So that kind of solution will be part of what will be in your diagrams, and you present it as a possible solution to the business. Then the other possible solution is to implement a network address translator, which allows the servers in the private network to reach out to the internet, but it wouldn't allow anything from the internet to go directly to the private servers. So that is also a solution within AWS that allows that kind of thing to happen. Now, some of these things may not really make too much sense for you for now, and to some of you guys that haven't even done Project 15 at all. But don't you worry, by the time we start implementing all of this, it will make a lot more sense to you. So we have a few more things to think about. So first of all, again, we have to determine what workload will run where and implement firewall through security groups. So again, you will start noticing that there's a whole lot of talk about security, because at the end of the day, you are using a public cloud solution. Anything that is public will definitely come with it with a lot of challenges. And so security has to be big as part of whatever solution that you're putting together. So we need to determine all our workloads, what is running where is our databases going to be deployed, where is our compute workloads going to be deployed. If we're going to have any kind of proxy servers doing any particular work, where are these going to be deployed? Once we determine all of that, then we need to start implementing firewall to limit access to exactly what we want them to be limited to. So security has to be fine-grained, defined, and implemented in such a way that you don't just open your network to anything. Okay. Then another thing is we know that servers have IP addresses. Okay. When you spin up a server, it will have its IP address. And of course, going to this website like this, we've just seen that we've gone to direct.io. The servers running our software doesn't actually have direct.io. Computers understand numbers. So we need a way to resolve a name that is human readable to an IP address so that when we put the name in the browser, it resolves into the correct IP address that goes directly to the server that is running the application. So how we do that in AWS, we have to think about it and put it as part of our architecture. So Route 53 is the AWS resource that we need to turn to help us to do that. Then the next one here says, how should our servers dynamically scale? So yesterday we talked about part of the well-architected framework, and scalability is a huge factor. Because when we are having growth, we're having a lot of students coming through the door, we have a lot of people implementing our projects. We want to weigh a situation where our backend servers can dynamically scale as well. We don't want you to log on to the servers to our website one day and all you're seeing is errors and you can't even work. You can't implement a project just because our servers are not able to cope with the growth that we're experiencing. So how do we handle growth like that? Scalability. So AWS have what is called auto-scaling groups that can be used to satisfy this. And we'll put it in our architecture. And when it's time to start implementing it, we'll see how all of that also works. Now, when servers scale in auto-scaling groups, new servers have IP addresses, which we never knew about. So the question is, how do we ensure that when these new servers come into limelight as part of our infrastructure, how do we ensure that traffic gets routed to them and customers do not know anything about that? Because remember I said that scaling is spinning up new servers from time to time because we're growing. Now, this domain name, which is our the name of the brand or the name of the website, routes traffic to an IP address or some compute address. But the question is, when we start having new servers that is part of the pool, what helps us to ensure that that server is rendering service to us and our customers still do not have to know anything about it? So one of the ways that is being done is to ensure that we resolve the human readable domain to a load balancer. So that means we have to start working with load balancers in AWS. Then we have to configure the load balancer to reach the auto-scaling group through target groups. So some of those terminologies are going to be coming up, from time to time. And as part of your implementation, you have to start getting used to it so that when you start for interviews, you can talk about them and not only just talk about them from a definition standpoint, but from use case standpoint, you know exactly what they're used for, when to use them, and how to implement them. So I think this is the last part of the slide. So I know it's getting a bit long, but it's very important that we go through all this. Then the next thing we'll talk about, how can we ensure that multiple applications can be deployed into the same infrastructure and reuse most of the cloud resources to save cost. So this is actually taking us to a real business requirement to be able to deploy multiple applications using the same infrastructure. It's just like our site. We have Dari.io. We also have a subdomain, support.dari.io. So let me just go to let me try to log in and go there directly because I may not have typed in the URL correctly. So let me just log in. Okay, so if I click on live sessions, okay, so it takes me to support.dai.io. And this is a typical example of what we're talking about because it's a website on its own. It's a microservice. It's completely outside of the main website, but still we're able to use it as part of the existing infrastructure, and we didn't have to create a completely new infrastructure to host this. Because if we did that, we'll be spending a lot of money and we're not satisfying the architectural requirements of saving costs. So what this is talking about is, let's read it again. How can we ensure that multiple applications can be deployed into the same infrastructure and reuse most of the cloud resources to save costs? So the same infrastructure we're putting together, it means we can even have a completely different domain. We can have Dari.io, we can have whatever, anything. Let me pick up some people's name. We have Chisom there, we have Moses, we have Onyeka, we can have Onyeka.com, we can have ijoma.io or something. Whatever domain it is, it can be a completely different domain, but using the same infrastructure, we can deploy the application and still reuse everything we've been talking about. The VPC, the internet gateways, the load balancer, we're reusing the same thing, but we're still servicing different customers. Okay. Then, okay, so route traffic from the internet to the, okay, so now it's talking about the possible solutions that we can implement to satisfy that. So we route traffic from the internet to the human readable domain name, pointing that to the public load balancer. So basically we'll point to a load balancer, and then the load balancer will forward the request to some reverse proxy, and the reverse proxy forwards to another load balancer and ultimately gets to the application. So that's going to be confusing. You know, I just won't dwell too much on this. Let's just go right into our diagram. Let's start putting things together, and then all of this will start making sense. So let's go back to the start, and then let's start with our virtual network. So what we're going to do is we have this pane right here. If you haven't used this tool before, let me just quickly show you. So there's a search box here that says search shapes. So if I put AWS, for example, in search, you can see it's bringing up a number of logos. So if you hover over it, these are resources that you can create inside AWS. So let me search for VPC and see if it brings up anything. So here you can see VPC pairing, VPC NAT gateway, VPC, another logo for VPC. So whatever it is you want to use, you can just come here, search for it, and if you feel like you want to use a logo as part of what you're presenting in your diagram, you can use that. And by the way, some organizations use different tools. Some may restrict you to using certain tools. In most cases, you're free to use any tool to do your diagrams, and you can just go here, export them in whatever formats that you want, and just make use of them. And then you have all these, I don't know what to call them, but these shapes that you can drag and drop and start making use of. So let's start with that. So let me see, I guess I'll probably want to use this triangle. So let's just drag that. Okay. And then what we'll then do is, let me search for AWS so that we can simulate that. Okay, now we want to start talking with AWS. I wish there was just AWS logo, Amazon. It doesn't really show more. Do we have anything like that? No. Let's see if I have one. I think I have one. Okay. I don't have anything like that. Okay, don't worry.
I think you can do AWS Cloud.
Okay, let's see that. AWS Cloud, AWS Cloud.
Yeah.
Oh yeah, that's it. Thank you. So we found something. So we could just drag that, put it there. Just put on the side, just to show that, okay, we're working with AWS. So the first thing we want to do is to create a virtual network, which is a VPC. So we can just put this here for now, and then we can drag. Okay, so we can drag this and put it inside. Let me tell you what this is trying to achieve. So within AWS, there are a lot of different organizations renting their infrastructure to run their businesses. So, for example, Facebook uses AWS. Harry.io uses AWS. Barclays Bank, GT Bank, different organization may be using the same public cloud provider. But what you want to do is you want to create your own space within AWS. So this is the entire AWS network. Now we are creating our own network within AWS, and that is this VPC. So we're going to have to right click and bring forward. Okay, there we go. So this is our VPC. And without just putting the logo there, we want to be able to know what it is. So I can just drag this text and just type VPC. Just put that there. So that goes to show that, okay, well, this is our virtual private cloud within the AWS network. So that's why it's called virtual private cloud. And this cloud, by the sound of its name, it says private. So when you create a VPC, it is private by default. So that means if we are here, let's find an actor. So this is probably, someone from the internet. Oops. Let me just drag it up a little bit. Okay. So this could be me, this could be you, it could be anyone. If you're in front of your laptop and you want to reach this network, so you have to go through, you want to reach this virtual private cloud. Obviously, it means you have to go pass into AWS network and reach here. You can't reach here like this. It's just not going to work because it is private. So this is not going to happen. There are things you will have to do to make this possible. Okay. So if we go back to our solution, it says virtual private virtual network. So we've created our virtual network. That's pretty much all we need to do. Just create that. And then how can we ensure that we can easily recover from disasters? How can we do that? So in AWS, you're able to deploy your resources or create your virtual private cloud into any region that you want. So let's say, for example, you're in the US and you want to service customers in the US. It only makes sense to select a region close to your customers because that's where the virtual servers that you'll be creating will be. So if someone goes on their browser and they try to reach your website, if your domain is routing to a server that is in Asia from the US, you can imagine how slow it will take them to reach Asia before it returns the data back to you. So it only makes sense that if your customers are going to be in the US, you select a region that is in the US. So that means this virtual private cloud, let's see if we can find something to represent a region. Okay, let's see the AWS region, anything like that? Nothing. Okay. So sometimes you can just use the text to represent what you're trying to do. So let's say EU West 2 is our region, and I do know that this region West 2 is London region. Okay, London. So that means the data center that will be creating will be in London. And the way AWS represent them, they have different ways of representing them. So some you see things like US East 1 or US West 2, or they just use the in terms of northwest, east, south to determine or to let you have an idea where the data center is physically located. Now, within London, you can then have availability zones. So in our case, we can have, because AWS will let you know how many availability zones is available within a particular region. So if you have selected London as your region, AWS will let you know that, well, we have 3 different availability zones. So it is now left to you to decide and say, well, I want to use all 3, or I'm just going to use 2. The implications of using either 2 or 3 is how much money you have to spend, or that you are aware that you're going to be spending. Secondly, how much is the level of availability that you want your service to have. If you want to have availability to 99.9999, then the more availability zones you use, the more available your service is going to be. Because if, for example, because sometimes availability is not about disaster occurring in a particular AZ. It could be that a particular AZ is slow because of network reasons. Even AWS have their own challenges that they have to deal with. Sometimes that network goes slow, and you can design your infrastructure in such a way that your load balancers understand that there is a slow network somewhere, and it just routes traffic to another availability zone, and it becomes a lot faster. So imagine that means the level of your availability is slow as well. But if you're using 3, even though you're spending a lot more in terms of cloud cost every month, it also means that whenever there's a problem with any of your availability zones, you know that there is a higher chance that your customers wouldn't have a lot of problems with you. So let's now assume that you had a series of meetings with your team, with the business, and you all decided, well, we don't have a lot of money to spend. This is a startup, and let's just stick to 2 availability zones. Maybe later, when we get well funded, we can then extend our infrastructure to more availability zones so that we can increase the level of our availability. Another thing is your nature of business could be running a product that has very strict service level agreement. What if you're providing service to another organization, and to work with them, they have strict level of SLAs requirements? So that has driven your decision already without thinking much about it. Because who knows, your customer that you're servicing is probably going to pay for the cloud cost anyway, so you don't really have to worry much about the cost in that situation. So you just go ahead, you design a solution that meets the requirement that the business has established. So let's assume, so let's remove this because for now we can't reach this, it's in a private network. But what we want to do is we want to now simulate that we're able to go via two different availability zones. So we'll drag our rectangle again. This time around, we can make it look like that. Okay, so let's just drag that down. And then we can make it a little bit like that. Okay, So what you can do is you can copy this and paste it and just drag it to the side. So I'm using my right arrow to drag, and I use Control V to paste it. So I can just drag it like this. Okay, let's see. AZ. Do we have anything like that? No, it's bringing a flag. Availability zone. AWS AZ. Nothing. Okay, that's fine. So we could use our text as well, and we could just say EU West 2A. So that's how AWS usually represents each of those AZs. So you can just say here, okay, this is our EU West 2A. You can copy Control C, Control V, and then put here EU West 2B, right? So now we have our two availability zones. All right, so we're getting there. So now we have to divide the network into logical groups. So let's assume that we have done series of meetings again, or as part of the different meetings we'll be having with the business, with our customers, whoever we need, whoever the stakeholders are, because that's where you're going to be taking all your requirements. So there has now been a decision that, well, we have to separate our networks into logical groups of the gateway, the compute, and the data. And by the way, sometimes these certain parts of the requirement are already established by other teams in the organization. And they're literally just going to give you exactly what to do. And that will just be part of your diagram. And you don't have to even consult anybody. The business has established exactly what it needs to do. Okay, you just take that in and just use that. And the reason also is because there can be a team, a separate team entirely looking after networks. So the whole network design may have been done already. And that's also possible if the organization is so large that, because it's possible to work with a very large organization and they're starting out with a new project, but that project has to integrate with some existing systems and some existing departments, and there's an enterprise-wide network that has to be considered as part of the design for the network. In such scenarios, it's possible that the design of the network has already been done by a different team, and they just tell you exactly how to implement it for your team and just integrate it with other teams. So let's assume you've done consultation, they've given you a requirement, or they have given you exactly what the requirement is, and we've come to the conclusion that we need to separate our infrastructure into three different categories. So we have the gateway, we have the compute, and we have the data. And I like to even put one more. We can possibly even have a proxy level. So we can have a gateway and still want a proxy that will not be in the gateway and outside of it. So let's just go in and first of all, separate our network. So let's use this rounded rectangle. And, so within this, okay, so 1, 2, 3, 4. Okay, so let's try to make this a little longer because this can become very quickly. All right. Let's try this out. Okay, cool. So let's just give some room. All right, so let's Control C, Control V, 1, 2, 3. So we can have one here, have one here, have one there. Okay. All right. So what you can then do is hold this. So I'm pressing command on my laptop. I'm using a MacBook. So I guess with Windows, it probably be control. So I've held on to the command and just clicking each of those rectangles. And then I did a control C, and now I'm doing control V so that I can duplicate all of them at once. So what this means is I can drag everything at once like this as well. So what this means is we now have 4 different subnets. And remember, this is an availability zone. Okay. Let me just write it here, AZ. So always remember, this is an availability zone. And an availability zone is basically another data center. It is just a way in which we are satisfying our disaster recovery requirement. So everything we deploy here, we're also replicating here, pretty much. That's what it means. So whatever we do here, we're also doing here. So anytime your application is servicing requests to your customers, it's coming from either here or here. So sometimes, you know, your application could be, someone is hitting this application right here, or another user could try to create a new session and it could be application running here. Okay, and it can, so that in terms of performance as well, so that it can spread the load. You know, you can imagine you have 1,000 customers visiting your website at the same time. You know, it can be divided between the 2 availability zones so that one is just not left idle. So this can be servicing 500 customers, this servicing 500 customers, and that way you're spreading the load. But at the same time, it can act as a disaster recovery solution so that if this whole availability zone goes down, all your traffic can be routed to one and at least serve your customers while you're trying to bring this other one back up. Okay. Any questions so far?
Yes, I have a question.
Okay.
Yeah. Since we are replicating what we are doing for one easy to another easy, are we going to be having 2 databases, one for each of the easy?
That's right. So when we get to the data layer, you'll see how that works. So you can have, you can have just one database, but you still have the other one in the other availability zone as well, serving as a read replica. So what that means is only one will be accessed when it comes to writing data to it. But when it comes to, and it can, the one that you are accessing that is writing data to can also be used as your read as well. So you can do both read and write. But you still have the other one in the other AZ, which can be used for read only. So that customers that actually needs to read, or application that needs to read data, to retrieve data, can go to that one instead. Okay.
Okay.
So it's still serving as disaster recovery because you can still fail over to that one, and the one that is doing read only can become a read write as well if you need that to be.
So how do you solve the problem of data replication?
So that's where
the consistency of data in both databases. Yeah.
Yeah. So all of that is inbuilt to the solution that a database management system like a managed service like RDS in AWS comes in, because data gets replicated and you can choose how you want that replication to be. You can either choose synchronous or asynchronous replication. They're both, pros and cons. But in terms of data consistency, data can be written to one place at the same time, but the data that is being written in one place will be replicated to the other one. Now, if you selected the synchronous replication, what it means is only when your primary database has confirmed that the replication has reached the other database and it is written to disk, that is when it confirms that its own write is complete. Otherwise, it doesn't consider that write as complete yet. And so that transaction between the application or the user to the database is not yet committed fully at that time. So that solves the problem of data consistency. You can always ensure that there is consistency between the data. So now, like I said before, yes.
So I have a question, not like a question. I just want to clarify. So
Okay.
If we are talking in that line of synchronous and asynchronous, does it mean that the trade-offs between when we have read replicas for something like a data lake or a warehouse would be more if we have probably two databases in different places, and one is working so fast, sort of.
Mm-hmm.
Would the trade-offs be much, or would it be minimal if we are working just with read replicas for something like dashboarding or analytics?
Okay, so let's first understand the difference between the synchronous and asynchronous, first of all, and understand the pros and cons. Then it becomes a thing where you have to make the decision of what works for your use case. For example, if what you care about is data consistency and ensuring that you don't care about the performance as long as data is consistent, then you can consider a synchronous configuration, because the latency that will be created just because the primary database is waiting for the replica to ensure that it is written and it does the confirmation, it takes time for that to happen, and that would impact the performance of your application, because that's when you try to imagine you're using an ATM. Okay, it's a banking application, you're using an ATM. Before your card gets returned to you, that transaction has to be complete. And synchronous replication is happening. And until that is complete, before you retrieve your ATM back and get a success transaction in front of you. So in that case, data consistency is the most important. You don't care about performance. But in the case of dashboard that you've just mentioned, or some data warehouse setup, now in that case, you're more interested in things like, because the way asynchronous would work is it doesn't care whether it writes to the destination, to the replica or not. Instantly, it just returns back to you your response. It returns back the response to you, it sends the data to the other replica, and it forgets about it. The performance in that situation is a lot faster, and that is if your requirements requires that performance is a lot more important to us than the consistency of data. And what are the situations that can occur that can make the data become inconsistent? It could be a case where when the primary database receives the request, okay, and then it sends the replica to the other database, maybe between that there was a network glitch, and for some reason that data didn't get to its destination. But the primary has written its own data and it has returned back to the caller to say, I'm fine. Now, in that case, there is data inconsistency that has occurred. So how to mitigate things like that? You may set some kind of monitoring that will alert you potentially that there's a data inconsistency happening, and you can go in and troubleshoot that. And But that, you don't really have to care much about that as a DevOps engineer, because this is now, we're going into database administration and management of databases. But it all comes down to what the requirement is or what sort of workload is. So if you're dealing with a data warehouse where, you know, you have to generate huge reports that sometimes even takes hours for the query to complete, you may care more about performance than a transactional database that's like a banking app that you just have to be on point with, you know, the consistency of data. So I hope that clarifies all of that.
Yeah, it does.
Yes.
Just one more question.
Okay.
Would you say that the RDS is read consistency? How do I put it now? Eventual write or eventual read consistency?
So of course there are default configuration for all these databases, depending on which one you're using, whether you're using MySQL, PostgreSQL, Sybase, whatever, you know, they have their default configuration, and each of them have their isolation levels, whether it's read committed or non-read committed. You know, there's a whole lot of configuration that can happen. Now, the reason why I know some of these things is because I used to work as a database administrator, and I can tell you, you know, how that side of things work. But really, most DevOps engineers don't even, it's not their work to do. It's not part of what you will be doing day in, day out as a DevOps engineer. Configuration of the isolation level that determines whether it's a read committed or not read committed and all that, it is specific to the database, the RDBMS in question. But if the default setting does not work with what you want, then you can then go into it and then change the configuration to what you want. So I can't tell you whether RDS, because what is RDS? RDS is basically Amazon's management database as a service. Okay. All right. So can we proceed?
Yes. Yes.
Okay then. So now we have our networks divided. Okay. Let's see.
Yes, sir.
So should workloads, okay, so we're talking about dividing the network into, so what we've done is, let's just label them. Let's label for now, we'll just label them. So this would be our gateway. Okay, this would be our proxy. So we'll talk about why we need the proxy in a bit. We'll have these as our compute. And then we have these the data layer. Okay, so that means now if this guy needs to come from the internet, he basically needs to, and then from here, we're still going to remove all these arrows. It's just to give you a logical view of the flow. So from the gateway, bring forward. I don't know why this is not showing the arrow, but anyway, you get the point. So it goes there, and then this can come here. Okay, and then this can come here. Pretty much. So something like that. And the same thing will be on that side. So whether it's trying to talk to this AZ or trying to talk to that AZ. But conceptually, this is what's going to happen. So for anyone to reach this private network, it has to go through the gateway. And this gateway is what we're going to now consider as our public network. Okay. So anything that has to do with public will come here. So that all these networks will remain private and only this one will be public. But before this can become public, initially, it would have been private because we would have created all these sub networks the same way. Okay, we would have created them the same way. But because our requirement is to ensure that our gateway is accessible to the internet, then we have to put configurations to make it become a public network. So this becomes a public network and every other becomes private networks. So that means still no one can go from here all the way to any of these networks. The only place he can go to is here. But the moment he gets to this network, because this network is both public and private, it has a private network interface. It is able to access every other network within the infrastructure. Okay, so that means to get to this, you have to come here first. So if we deploy any server, let's put EC2. So you know what an EC2 means, you've been doing projects all this while. So all the servers that you've been creating, those virtual machines, that EC2 servers. So if we had a server here, we can also, of course, we'll have servers in all these other places as well. Okay, let's have more servers. Okay, so that means if you want to do your SSH, let's assume this is going to be SSH. So I've just double-clicked this arrow. And of course, you all know what SSH is because you've been doing your projects. You can SSH into any of the servers in this public network, but you cannot SSH directly into any of these servers. Okay, so we're beginning to design our architecture and making sure that, now we're putting some controls, we're making sure that, we're secure and all that. Okay. All right. Then should what storing data be within the same network? We've satisfied that. We've made sure that there is separation. Should our servers be accessible directly over the public network? So now, because we need these to be accessible over the public network, only the public network, we need what is called the internet gateway. So this is a software component in AWS that makes it possible to access the internet. So we can put this, just put it here. So we just put it at the edge of our virtual private network. So what that now means is this will have to go through that. And because of the internet gateway we now have, it's not able to do the traffic here. So it is this component that makes it possible to reach this network. Without this internet gateway, we cannot reach this network. So this is a software component where we'll deploy in AWS. And you see how all of that works. Then the next thing is, how should our engineers access servers in private networks since private servers can never be reached over there? So we've talked about that as well. So because we now have a public network, we have servers that can run here as what we call bastion servers. So you can have your bastion in here. Okay. So a bastion server is a gateway server or a jump box. So we also call it jump box. So it's basically a jump into the network. So you jump on this host first of all, and then you can access all the other servers. Okay, so we're making progress. So we'll go to the next page. Now, is there a requirement to access the product from the internet? We need an internet gateway. We've done that. And then we need routes as well. So there's something called the route table and route configuration. So let's see. Route table. Okay. So we have a route table here. So what these does, you can see it has like IP address in it. It's just like a table. that has rows and columns that says, okay, from this IP address, network can be routed to that IP address. How traffic should be routed within the infrastructure, because we have this virtual private cloud that will have IP addresses, and it will hold a certain number of IP addresses based on the configuration we give to it. For example, it could have 10.10.10.10/16, which means that we can have a certain number of IP addresses. There's a website, CIDR calculator, so you can use that. So it gives you an idea of how many IP addresses can be generated from a certain range. So if I put 16 here and calculate, it tells us that we can have a total host. A host is a server. So you can have a total host of 5,536 just by having this configuration. So if we defined our VPC to have this CIDR range, it means that the total number of servers that we can create in the entire private network will be 6,500 plus. Now, dividing these into subnetworks is now extending that CIDR range. So we can then say, well, what would /24 give us? It will give us 256. So if we feel like we don't need more than 256 per network like this, then we can subdivide this network and say this would have /24, and this can have /24. So you can play with the numbers here to determine how much. If I do /23, this will give us 512. If we do /8, this gives a total of 16 million. So now, network administrators, there are people who are professionals in understanding how all these IP addresses work. There are different classes. You hear things like class C, class B, this and that, So there are ways in which these are calculated with binary numbers. It's not something that you will have to do a lot. Having basic understanding about it is fine. You just still have to understand some of the concepts. At least understand that, okay, when they're talking about CIDR ranges, how ranges of IP addresses are discovered, you know what they're talking about. You're in meetings, these kind of discussions come up, you are not completely lost. Okay, so this is how the networks are subdivided. And then the root table basically holds information to understand how do we route traffic from servers holding a certain range of IP to another range of IP. So that's what this whole root table is all about. So we can create a root table and just, put it here. So you can just have a root table that has roots configured. So each of those are roots. So there's a table and then there are roots. Okay. So, so traffic routes, configuration. Do we need our private network to download stuff from the internet? So we talked about this earlier on. How do we ensure that even though these are private servers, how do we ensure that if we need to download stuff from the internet, we can go out to the internet and download things? Because this is not going to work. Internet gateway is only for inbound. It's not for outbound. So we need a way to ensure that we're able to go outside to the internet to download stuff. So one possible way is to consider one of the servers here in this public network as a proxy. So one of these EC2 servers, you can just dedicate it to be a proxy, and it will serve as our repository in-house. So that if you need to download anything from these private servers, you just go to that proxy and download stuff. That proxy has already done scanning, antivirus, and everything is running on there. And of course, you don't want to be running antivirus on the same server that your applications are running. Antiviruses are very, very compute intensive. They use a lot of resources that can eat into what your application requires. So one of the ways to deal with that is you can have a proxy server here, and it does all the scanning. You can make it become a web server that hosts everything that needs to be downloaded from the internet. So that if there's need to then download stuff, you're actually downloading from a server within your network. And that server has taken care of all the vulnerability scanning and all that. So that's one possible solution. The other solution is to have a network address translator that allows you to go directly from this server to the internet. It is much more secure because obviously you're not going to the internet. It's a lot more secure, but it has a lot of overhead because every single thing you want to download has to come through that. And it can be a pain sometimes if you're within your dev environment, you're trying to do something, even to run command to get something from the internet, it's not going to happen. Then you have to go through this one first of all, and sometimes you probably won't even have access to it. In some cases, as a DevOps engineer, developers may not have access to it, and they'll have to start request about it. Is already introducing something for software to be developed and released and make life easy for everyone. But at the same time, doing all of that, you're able to do it to achieve quality standards. So what AWS allows you to do is we can actually implement what is called a NAT gateway. So that NAT gateway is literally doing what that proxy could have been doing for us. Okay, but it is a managed service that Amazon takes care of. Behind the scenes, it's also a server that is doing all that. So what we can do is, let's see if we have NAT gateway here. NAT, okay, we have an icon for it, VPC NAT gateway. Okay, so if we look at, let me have a look at one of my notes here. Let's see. Okay, let's minimize this and make it a little small because our diagram is becoming a bit clumsy. But what is important is that you're able to see the design from ground up, and you won't see a diagram and just like what's going on. At least you're able to see how everything is building up. So what's going to happen is, let's make this a little small just to give some room. So in our public network, we can deploy a NAT gateway here. So what's going to happen is, for this to download anything from the internet, it would go through the NAT gateway, okay? And then, because this is a public network, okay, then this can reach out to the internet, download the stuff, send it through the NAT gateway, and back to whichever server requires it. It could be this, it could be servers from this subnet, it could be from this, it could be from that. As long as these are private, they can't reach the internet, they will have to go through the NAT gateway, which is part of the public network. So because this has been isolated as a public network, anything that has to do with network public stuff will be done in this network right here. And you can see imagine we didn't have to separate this, and it's still open with all the 65,000 network and everything. That means there is no difference between private, because the internet gateway that is being deployed here has made everything public. and we're just open to all sorts of possible threats. Okay, so we've done that, and let me ask, would you want us to proceed? We have this slide and this slide. We have 2 more slides. Would you want us to proceed? We still have about roughly 20 more minutes. Are we having information overload already, or do you want us to carry on?
Carry on.
Carry on. Okay, good.
Let's go.
Okay.
Yeah, please
Okay.
carry on. Please. Bye.
Okay, brilliant.
Yeah,
All right.
hello.
So, yes.
Yeah, so looking at the Bastion post and everything on the first part, yes. Now, if we are kind of scaling, and let's say we have like maybe 5,000, 10,000 users, and this is working fine. So let's say we did some kind of good marketing and our user base just jumped to 100,000 within 1 week. Won't there be any problem traffic-wise, looking at the entry points of users from that gateway accessing other services?
Okay. So remember that this is not a service that we manage. This is a service that AWS manages for us. It is a software that is provided by AWS. And everything or any service that you are plugging into AWS to give to you, always know that AWS has taken care of anything that has to do with scale. They own the scale, they have the infrastructure. You don't have to worry about it. The same thing has to do with even this NAT gateway. Whether you have a spike in your traffic, it's not something that you're going to care about. AWS takes care of it. It's a service, it's a software, and it's not like servers that you're provisioning and you're configuring how you want your scaling to work. If it was our own servers that were deploying our applications, we'd have to think about how much of scale do we want to be able to configure, because you can even configure to have a maximum level of scale. But in this case, it's something you want to worry about. It's a managed service. AWS takes care of it, and that's it.
Thank you.
Now we have this part that says determine what workload will run where and implement firewall threat groups. So this part now, we know that we have our proxy running here, we have compute, we have gateway. What you don't want is, for example, this is a proxy subnet, and it has servers running here that's only doing proxy. And what is a proxy? A proxy is just something that's standing in between, that is accepting requests and forwarding it on. The reason we have a proxy here is to satisfy that requirement of running multiple websites using the same infrastructure. So we can have an Nginx reverse proxy here, put some Nginx configuration that listens for the traffic, understands who requires this, and forwards it on to the respective application running whatever software. Now, this proxy has no business with the database. So if you have your RDS running here, it has no business. So even though they're within the same infrastructure, you still want to treat them like they don't trust each other. So if there is no need to allow traffic from proxy here, then you have to lock the firewall from allowing anything here to come here. Because you have to think about it. What if, for whatever reason, a malicious to get into our private network, and they're able to also get into our proxy? If there is access to the database by poor design, that means we're open to a lot more risk. So you want a situation where even when there is a a threat that has occurred, you want to limit the damage, the potential damage that will happen. And this is part of the well-protected framework that says that you have to plan and think about all these things from happening. You have to plan it. In some cases, but in most cases, you have to even practice it. You have to simulate that you've been hacked into and how would you respond to it. It should be part of your design. So what we're going to be doing here is we're going to make sure that we have firewall that is properly configured across these. Now, in this, it might become a bit more messy when we start drawing arrows to say, oh, this is a security group, this and that. So this is where things like documentation that are appended to your architecture comes in. So you can have a different documentation that documents the firewall rules and your plan in terms of firewall, in terms of who can talk to what. So in this case, we know that the compute resources needs to talk to the database, and some compute resources don't even need to talk to the database. You can limit that access as well. So even though there are servers running in this subnet, some servers can have access to the database, and some may not even have access to the database if there is no requirement for it. Okay. Similarly, even the public network here, if there are no servers here that has business with the database, there's no need to create access. And by the way, the fact that this is public, the fact that this is a database, there shouldn't be any connectivity between the two. It's between the network and the proxy on protocols. That's another thing. For example, the access on HTTPS protocol, which your user, it has no business with your backbone, okay? The business it needs to have is with this proxy because it's coming straight from the. So you can create firewall between the level coming all the way from here to this place. And the traffic that is coming from the internet, it's not coming directly. There's no need to open up access from the internet to these ones right here. Now, I know this can be a bit confusing to you now because you already said that, oh, but from the internet, you can't come here directly. If we read further down, we'll start talking about load balancers. Okay, so yeah, we know we need a load balancer somewhere. So let's just create that load balancer. Okay, so there is a load balancer here. There's different kinds of load balancer, but let's just choose it. Okay, you can use the application load balancer. That's fine. Okay, so this is now going to change. So, well, actually, I'll still leave that because that is for SSH here. But for HTTP, so I just put HTTPS because we want to make sure that there is a secure traffic. All right, so it's coming all the way from the internet. It's hitting a load balancer to this proxy. Okay, good. It's able to come to this proxy. Now, the only reason why this will happen, we'll be able to flow through is because of this internet gateway, because we've created a load balancer that is going to create because we need these to come from the internet, we will create a public load balancer that is able to talk to our infrastructure. So we're coming through the HTTPS protocol. We have no business with anything running in this gateway, subnet. All right. But of course, we have routes. So the root configuration here that has this internet gateway is what is going to make this load balancer to work. And for that reason, is able to accept the traffic, and then ultimately is able to route that traffic to the servers that's running inside our private network. So because we now have this proxy running here that now accepts the traffic, and this is the one that will understand which of our subdomains or which of our domains or which of our applications needs this particular traffic that is coming through, then it does the forwarding. But again, you can start wondering, okay, well, if we have auto-scaling groups of these compute resources here, and we have, let's say, okay, let me delete this. At least we know that's compute. So let's say this is auto-scaling for one of our applications. And this is another of our applications, part of an auto-scaling group, okay? The question is, how would this proxy know that it has to talk to all these, any of these servers? Because these servers are going to have IP addresses. So this is where we now have to also implement another load balancer. This time around, it's going to be a private one, so that this proxy can then route traffic to it. Let me see if I can. This thing, how to drive that. Okay. So this, rather than going directly like that, it goes through this load balancer, and this load balancer becomes smart enough to know whether it needs to talk to this application or it needs to talk to that application. So things are becoming a bit messy. I understand that, but what is more down? And it may look like, oh,
Not going to satisfy our level of availability because that one server can die. Anything can happen. Somebody can just go in and trigger it off and just click on stop. Anything can happen. So when that happens, if that server was part of an auto-scaling group, even if you click on stop, it will spin up a new server, and there will always be a server available to service the request. So because it's possible that servers will die and
Testing your speakers on StreamYard. Sounds like they're working. Have a great show. Testing your speakers on StreamYard. Sounds like they're working. Have a great show.
This song is brought to you by Kelsey and Presley and StreamYard support. Have a great show.
SSH from here. Now you're inside the bastion. Then there can be firewall. Ideally, it's better to have it here and not have servers running in here at all. So what you can do is you can then put security group access from here to here. Okay, so that when you get here, then there is firewall security groups also from here to here that allows you to go directly there. So you can just go through that hoop and ultimately get it.
Hello, sorry.
Another,
how can we get the recording for yesterday and today's class?
yesterday's class recording had been shared already. So if you haven't received it, you can either check your email or after this class, just send a message and we'll take it from that.
Yeah, I got the email.
Okay. Before I forget, I wanted to say something about this. I was going to say something about this routine of. Okay, yes. So what I've also seen happening a lot of time is you see this that you can provision to run as a client. Sometimes you can have it provisioned. It could be part of an auto-scaling group that will only have the setting sets to 1. That means it will always run one client server all the time. But it will be set to 1 just if it's a production environment, a production database you need to access. That client server will database, you have to raise a request. It has to be approved. Then that server will be turned on. Then you can SSH into that server through the public network. You go through the bastion and go all the way there because now it's turned on. And then you go into the database, do whatever you have to do. And after the work is done, you shut down that server. and that way no one has physical access to the database. So those are ways in which you can handle things like that, and that can be part of your design.
I just asked a question. What do you mean by it return to one?
Okay. So let's say this is our auto scaling group, yeah? And in auto scaling group, you can set figures of what's the minimum server that has to be running at every point in time, what's the desired when there is scaling activity. So you can say, okay, starting with 1 because I have just 100 users. But when there is CPU usage going to like 90%, then scale my server to a maximum of 10. Okay, so it will start with another one. So you start running with 2 servers. The CPU keeps spiking to 90%. I keep saying 90%, and then another one keeps running, and it keeps scaling servers, and the number keeps incrementing. So when I said 0 and 1, what I was referring to is, if you created an auto scaling group for the client, you can always set the figure to 1 so that it will never scale beyond. Because the purpose of this is not to scale application, it's just for the client to access the data. Yeah. So you always set it to 1 to turn on the server. Once you don't need the server anymore, you set it to 0, and it destroys that client, and it never comes up. The reason why you want to use auto scaling group for this is you don't want to always go into your AWS and select to launch an EC2 server, and then you search for an AMI, and it comes back up. You then have to do your apt-get updates to install your packages, install MySQL clients. That would take a long time. As part of configuring auto scaling group, you will have what is called a launch template. So that launch template already has definition of how this server should come up anytime you need it to come up. So when you set it to 0, it destroys the server. When you set it to 1, it brings up the server, install all those packages, does everything automatically, and all you have to do is just log in, and everything is ready for you to go. So that's what I meant when I said to set it to 0 when you don't need it, set to 1 when it's needed.
That's a very good way of doing it. Thank you very much.
You're welcome. And again, another reason why you set the numbers is because if you set it to 1 and you go in your AWS console, let's say you finish working and you stop the instance is not going to stop. It will stop initially, but what's going to happen is auto scaling group is set to 1. It will always spin up a new one. So you can never stop a server running as part of an auto scaling group. Its auto scaling group would always spin it up again because that's what it's meant to do. The desired state of the infrastructure will always be checked with the current state. If the desired state is 1 and the current state is 0, just because you stopped it, it would always trigger another one to make sure that the desired state is what is running at every point in time.
Hello, Darren.
Yeah.
Okay.
Hello.
So I just want to get clarity of the database access. I know you mentioned something about switching on and switching off. Like, then if there's need to access it, there will be room for getting permission to do so. So now that's for someone like an infrastructure engineer that can do SSH and pass through all those processes.
Yeah.
Now, one of the developers just need to do a one rough job on the database, and it's very important when a particular MySQL script on it, and they can't go through that route to do the SSH and stuff like that. How can you give such a person, or instance, how can you help the person access that database when there's, even though you're going to turn it off back, but as at that moment where the person needs to use a tool that is familiar with the person to gain access in.
Well, so as part of operational excellence, first of all, no developer should be allowed to touch production databases under no circumstance should that happen. If that is happening in any team, that is an anti-pattern.
Testing your speakers on StreamYard. Sounds like
of this is real time, this is real life data of users, we're having problems. So that kind of scenario, what would you do? Would you
So,
still advise not to get
I
into
think I
production?
think I missed you there. So what was the problem with the production data?
Okay, the production data is we are talking of real life users data, while in UAT we're having it was
To DevOps logo and just pick one of them. Okay. So let's have a look at this one. It says build code plan. Oh, what is it? Oh, plan code, build, test, release, deploy, operate, monitor. Okay. The scenario you just painted is a typical one where, first of all, you don't even know the problem, first of all. So you need to go into production to go and start debugging, right? But if you had proper systems in place that does all of this, you probably won't even find yourself in a situation where you need to go and start finding the problem in production, because you would have systems that's doing proper monitoring for you. And one of the tools that you would use in this kind of situation would have been Elasticsearch, for example. With Elasticsearch, you have all manner of logs that gets shipped there. Database logs, application logs, and all that. So before you even go into production, you can have Elasticsearch, and some of your developers can have access to production Kibana that visualizes production data. Okay, not all developers, maybe the tech lead can have that kind of access. Read-only access, just to be able to go into the logs, because all the logs can be consolidated. I've found myself in several situations where the problem gets figured out in the first place from going through the logs in Kibana. Okay, so you don't have to go into individual servers to start grepping through the logs and doing all that. Everything is consolidated in one place. So you can filter by dates, you can filter by things, filter by applications, filter by databases, and right there, you can figure out what the problem is. Once you figure out what the problem is there, then you can decide the way to fix it. Now, that can only happen when there's proper design, tools, decisions have been made, everything has been deployed, you have CI pipelines and all that, and you're not going into production to find out the problem. But of course, if the foundation is bent already, then you don't have a choice but to then go into production to start doing things that you shouldn't be doing. Because the scenario you painted, we don't even know the problem. it is only when you know the problem that you're able to come up with a solution to fix it, that a developer can come up with a script to go to production and fix it. But we need to find out the problem in the first place. And you can't simulate the problem in UAT or any other environment. You have to go to production. But if you had proper monitoring and logging in place, you wouldn't find yourself in that situation in the first place. So of course,
but they can take a backup of the database,
So
put in their test environment.
yeah, so I was actually going to go into that. So there's another solution that you can use. So for example, if you were using something like Amazon Macy, so there is a product that Amazon provides, Macy. You can actually take a backup of your production data, put it into your lower environment, and then the sensitive data, you can use Macy to capture those. And then there's a terminology they use, but it basically just makes sure that sensitive data is not being accessed by
deduct. I think they will deduct it or something.
Exactly, you do deduction or whatever it's called, basically, just to make sure that you don't. But in some cases, even that may not be possible, because sometimes you can take a backup like that, put it into lower environment, and still you can't replicate that. You may still need to put some other tools. Okay, that's where, when we start working with Kubernetes, some concepts can then start coming up, because there are solutions nowadays that you can actually test in production. Okay, so the way you can do that is you can replay exactly what's happening in production in a separate environment. You do that replay, it's still in production, but it's also been redacted. And there's a whole lot of things that can still be done. It all comes down to understanding what tools to use and how to use those tools. But again, you have to have designed something, implemented these things, anticipate them, practice them, test them. You can't be practicing them when production is hot. When production is hot and you are in a very serious situation, you will do serious things. Seriously. So, planning takes a huge part of all of this. There's a whole lot of deep thinking that goes through it, research. Okay, some of these things as a solutions architect, you think about it and you even get your team to simulate it and practice it before things happen. And because you're thinking about it, you'll come across tools that can help you to handle them when situation arises. And discovering those tools can get you to then create tickets and say, we need to use this tool, we need to deploy this tool, we need to see how this thing works. Those kind of discussions can start coming up, and then you can drive your team towards that direction. All right.
Yeah, thank you.
Okay, so we've spent a lot more time than we should. We should have ended by 10 o'clock, but it's good that we have questions as well. But from next week, we're going to start implementation. Those who are still trying to catch up with Project 15, please go ahead, try to catch up before we meet again. Those who have completed Project 15, do not stop, carry on. It's better for you to be way ahead of the class than to be behind the class. So if you have any further questions, feel free to send your questions in Slack. I'll be there as well to respond to you, or any of the mentors on the platform will be happy to also respond. So thank you very much, guys, for hanging out with me this evening, and wish you the best Express this week, and then we'll catch up again next weekend.
Thank you, Derek. Bye.
Thank you.
Okay.
Thank you, sir.
Thank you very
Good
much.
night. Thank you.
Good night, everyone. Bye.
Thank you. Good night.
Recordings.